Alright, so we're going to cover an interesting little topic here. If you're familiar with data structures, you might have heard of something called a linked list. And it's helpful to think of a linked list as a bunch of objects tied together by a string um, in the abstract form. In code, it's actually a bunch of objects tied together by pointers, so you can see the parallels. Anyways, it's a way that we keep track of data and we can link it together, hence the linked list. So we're going to talk about two common methods that you see with linked lists, and actually you see it with every linked list. It's not a linked list without these methods. These two methods are going to be append and remove, and I wrote up a little main function here. I'm just going to walk you over the quick steps that we do. It's only 3 main steps, and then we end the function down here. So we're inside of our main function. The first thing that we do is create a linked list. Simple enough. We're going to append an element to the list. In this case, we're going to append an integer of 100, or a value 100. Next up, we're going to append another element to the list, which is this integer value of 200. And then we're going to remove that value from the list, so 200. And then we end the program. So we're going to use this useful tool called the GDB debugger. And I recently just learned how to use this, so forgive me if I don't know all the ins and outs of it, but what's cool about it is it's going to let us step through our code one by one and see what's going on. So this will allow me to explain the steps of everything that's going on so far. So without further ado, let's jump right in. First thing we're going to do is run our code. So this program, I called it main2, and we're going to run it by clicking this little debug button right here. Okay, cool. You'll notice that the program stopped at this red line right here, and I have 3 of them here. What these are called is called breakpoints, so you can tell your program to run to a certain point and then stop, because you want to see what's going on at that point. So you notice that to add a breakpoint, all you do is go into this little margin right here, you click a red dot, and then to take it away, you just click again. So very useful tips and tricks. So let's get into it. So this first command, the list.append 100. So we're trying to append this value of 100 to our list. Our list should be empty, and we're going to put 100 on it. So let's click step into, and what this is going to do is going to dive deep inside and figure out what's actually going on in this append method. Okay, so what's going on here? This file right here is called linkedlist.hpp. This is going to handle all the background that's going on with the actual linked list. So I have a bunch of code written here, something that you shouldn't technically worry about. We're just going to follow the steps as we go along and see what the result is in the end. But just know that this is where I built the linked list, and every little function that it has, every data method or data variable or attribute that it's concerned with. But that's not necessarily important to understand for this tutorial. So the first thing that we do here is we're going to create a new node, and that's what this line of code does here. We're going to use this little thing right here, step over, in order to walk through each step. So let's click this. So we created our node, and we're going to assign the value inside of the node to this variable a value. Now this was just something that we passed in, and recall that we passed in 100, so it's going to put the value inside of the node equal to 100, and you can see the confirmation of that right here. This right here is just the address of the node in your computer's memory. Next step is going to be this. So we're setting the new node next pointer to null pointer. What that means is that we're creating a node in space. We haven't actually attached it to the linked list yet, So we're just creating this node, and we're telling it point to nothing for now, and in the next couple steps we'll tell you what to do. So let's see what we tell it what to do. Okay, so the first case, there's a whole list of cases here, but the first case that we run into is when you have an empty linked list, and you'll see the little comments here that say, if there are no nodes in the list, make new node the first node. So what this code does is it's going to test the head pointer to determine whether there are any nodes in the list already. So the head right now is pointing to null, which means the list is empty. The head's pointing to nothing because there are no elements in the actual list. That condition is true. We put an if condition there to check that case, and that condition happens to be true because we have nothing inside of our list. So we're going to set the head node to point to this new node that we created, thus adding an element to the list. This is called appending. Then we're going to return the appended node. This is just something we had to do for our assignment. We had to return what the new node was, or a pointer to the new node that we appended, but you don't necessarily need to return this if you don't want to in order to create a linked list. You could have defined this function as void here. We just happen to define it as node pointer because we want to point to whatever node we added or appended here. You'll see a similar case for the remove function that we cover in the next two steps. So once we're done with that, we end and we jump back to the program. So we just added 100 to our list. Simple enough. Now we're going to repeat that same process for the value of 200. Now we want to add 200 to the list. So we step into here. We're creating another node. We assign a value of 200 to it. And we tell it to point to nothing for now. Now it's going to check again, is the list empty? And that shouldn't be the case this time, right? Okay, well it wasn't the case. That's a false condition. The list is not empty because we added 100 to it. So we jump to this else statement, which says, if the list isn't empty, insert the new node at the end. And that's what append means. It means you append it to the end of the list, or you insert whatever element you're trying to insert at the end of your list. So let's walk through these steps of what happens in that case. We're going to initialize the node pointer to the head of the list. This node pointer is just something I use to keep track of what pointer I'm currently talking about. That's all you need to know, is that this node pointer is pointing to the current node. And you'll see what I mean in a second. So we're going to start at the head of the list. And you're going to find the last node in the list. So you'll notice this while condition here. While node pointer has a next, node pointer is going to be equal to the next pointer. So what this is going to do is actually iterate through our list and find the end of the list. That's like the overlying concept here, and you don't really need to know much else if you want to dive deeper into this code. This is how you iterate through a list. You basically define a pointer at the top, and you start from the beginning of the list by setting it equal to the head, and then you keep going until your node pointer eventually doesn't have a next pointer. It points to null. That's when this condition would break out of this loop and jump to whatever next line of code you had. And in this case, we jump to this line of code which says, let's set whatever the next thing that the node pointer is pointing to equal to this new node, thus attaching effectively the new element that we defined to the list, or we're attaching 200 to the list now. So that's what happens there. Again, we're just returning a reference to the node, not very important. And we exit the function. Cool. So we just attached 100 and 200 to the list with these two commands. The final command right here is removing an element from the list. So what element do we want to remove here? Well, we said 200. We want to remove it from this list. So let's step inside and see what's going on. So again, we're checking if the list is empty, and if that's the case, we want to do nothing because we don't want to remove something that's not there. If the list is empty, we don't want to remove anything from it. That's actually not true for our case here, so this is actually going to result in a false statement, and so we jump to here instead. So we're going to determine if the first node is the one that we want to remove. Well, we said that we want to remove 200, which happens to be the second node in our list, so this should result in false. So we're not actually going to worry about these details right now. Okay, so we skip over that if statement, which will do what we wanted to. If you had the case where you wanted to remove the first node, this is how you do it with these lines of code. But that's not the case for us. So we're going to jump to this else statement. And so again, we're going to iterate through the list. So we set node pointer equal to the head. And we're going to skip all the nodes whose value member is not equal to the value that we told it to remove. So we said 200. We don't want to remove 100, we want to remove 200. So we're going to search through the list and find that. And that's what this block of code does here. So you'll notice that it goes through the list once because it said, oh, well, that first value 100, that's not the one we want to remove. Then this thing updates it. It says, okay, let's point to the next element. So node pointer equals node pointer next. We're going to go through the loop again. And it's going to see that, oh, this is the value we want to remove. So this should jump out of that loop now. And then now we're going to check if the node pointer is not at the end of the list, link the previous node to the node after node pointer, then delete node pointer. So this is the case that the node that you want to remove is actually somewhere in the middle of the list. This is not the case for us, so we're going to see that if you notice that essentially like we removed the node within this code right here, but this case right here actually defaults to down here if that's the case up here. So this whole chunk of code takes care of this condition up here. So you'll see that we end the function here. Again, essentially what happened here is that our node, this is something I defined as the node that we want to remove or a pointer to that node. And we're going to set it equal to node pointer. The previous node next is equal to node pointer next. What that means is that you're essentially cutting out a node from the list, and then you want to return a reference to the node that you removed. So once that's done, we again return back to the original main function, and then we end the program. So all we did was we added 2 elements to the list, and then we removed one of them. So that's essentially how the append and the remove work for a linked list, and I hope this was informative. So I hope you enjoyed, and see you on the next one. See ya.